Here's 7.1, interior and exterior angles. And can you guys give me a thumbs up if you can see my PDF that says 7.1, interior and exterior angles? I just want to make sure we're all like here. Nope, you cannot. Okay, so let's find out why it's not doing that. I need to share a different tab. I need to stop sharing. Let's go to present. We're going to do my entire screen. Screen 1, share. Can you see 7.1 interior and exterior angles now? Yay, I figured it out. Okay, so we have an essential question. What can you say about the interior and exterior angles of a triangle and other polygons? So the first time through, you're just listening and following along with this as I go through it. And then you'll go back and take notes. So it helps you from maybe missing something if you're trying to write something down. All right, so explore 1, exploring interior angles in a triangle. You can find a relationship between the measures of the 3 angles of a triangle. An interior angle, so this is a vocab term right here. I'm going to get my stylus to do this. Oh gosh. So I'm going to turn off my camera and I'm going to flip my screen around so that it's a tablet. Okay, but you guys, I do have our Google Meet open, so if there is something that you're not hearing or getting, you can always type a question in there or raise your hand or something. I should be able to access that. Okay, so interior angle. All right, that is our vocab term. It's an angle formed by 2 sides of a polygon with a common vertex. Okay, a vertex, let me just show you in case you forgot, is like these points right here. These are vertices. Okay, plural is vertices. So a triangle has 3 interior angles. So this activity would say that you use a straight edge to draw a large triangle on a sheet of paper and cut it out. And if you tear the 3 corners off and rearrange them so that the angles, rearrange the angles so their sides are adjacent and their vertices meet at a point. So they're taking the 3 vertices here and then rotating them around so they all touch. Okay, what seems to be true about placing the 3 interior angles of a triangle together? So in the chat, if you think you know what's true about those 3 angles, you can type it, or you can raise your hand and I could call on you. Anybody remember this? I know you guys learned this in 8th grade. Okay. Nobody knows? Well, they form a straight angle. Okay. Make a conjecture about the sum of the measures of the interior angle of the triangle. Well, this is pretty important. The sum of the measures of the interior angles of a triangle is 180 degrees because a straight angle is 180 degrees. The conjecture about the sum of the interior angles of a triangle can be proven, so it can be stated as a theorem. In the proof, you will add an auxiliary line to the triangle figure. An auxiliary line is a line that is added to a figure to aid in a proof. So this right here is a main idea. When you do take your notes, this is super important. It's the triangle sum theorem. The sum of the angle measures of a triangle is 180 degrees. And so we're going to look now at a proof of this. We're going to fill in some blanks to complete the proof of the triangle sum theorem. So given triangle ABC, we're going to prove that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees. So in this proof, we have our statements to the left and we have our reasons to the right. So every time we make a statement, we're giving the reason why mathematically it's true. Number 1, draw a line L through point B parallel to segment AC. And you can see in the picture, line L is here, okay? And it is parallel to AC. These two lines are parallel. And the reason why we can do that is the parallel postulate. Number 2, the measure of angle 1 is equal to the measure of blank, and the measure of angle 3 is equal to the measure of angle blank. Okay, so if I'm looking at the picture, all right, the measure of angle 1 is equal to the measure of angle 4. So I'm going to put A4 right here. And the measure of angle 3 is equal to the measure of angle 5. Sorry. Angle 5. Okay, and the reason why this is true, we have to give a reason why it's true. It's because of the alternate interior angle theorem. So in this box, we would write this. Okay, and then for step 3, the measure of angle 4 plus the measure of angle 2 plus the measure of angle 5 is equal to 180 degrees. Okay, so for step 3, right here, what they're showing you is that these 3 angles are adding up to 180 degrees. Okay, that's from angle addition postulate and the definition of a straight angle. Straight angles are 180 degrees. Number 4, measure of angle blank plus measure of angle 2 plus the measure of angle blank equals 180 degrees. So we're back to what we're trying to prove, which is that when we add the measures of angles 1, 2, and 3, we get 180 degrees. Okay, and the way we did that in this proof is by the substitution property of equality. So that's a proof. That's our first one. Okay, we are halfway through our notes. Are you guys following along with this? You can see my screen. I'm not just like projecting nothing, right? Okay, good. If it happens where I am just projecting nothing, you need to just come on and tell me, because otherwise I'll just be talking to nothing, and we don't want that. So the other page we're going to look at is page 317. We're skipping quite a bunch from 313 to 317. All right. And this is the other main idea. It's the exterior angle theorem. Okay, so an exterior angle, this is some vocab right here, is an angle formed by one side of a polygon and the extension of an adjacent side. So there's a picture of that. So if, like this example, the polygon is a triangle and the extension is this piece right here. Okay, so the exterior angle is right here. And exterior angles form linear pairs with interior angles. So these two interior angles are right here and right here. And they're opposite, they're remote, they're away from the side of the triangle that we're using the exterior angle of. Example 2, follow the steps to investigate the relationship between each exterior angle of a triangle and its remote interior angles. Step 1, use a straight edge to draw a triangle with angles 1, 2, and 3. Line up your straight edge along the side opposite angle 2. Extend the side from the vertex at angle 3. So they're just showing you how they're drawing this picture right to the right with angles 1, 2, 3, and 4. You've constructed an exterior angle. The exterior angle is drawn supplementary to its adjacent interior angle. Do you guys remember what the word supplementary means? If two angles are supplementary, how much do they add up to? Any ideas? You can type it in if you know. It's saying that this angle and this angle are supplementary. That means they add to 180 degrees. That's what supplementary means. Step 2, you know the sum of the measures of the interior angles of a triangle. All right, we just figured that out. Measure of 1, 2, and 3, we just figured out is 180 degrees. And since an exterior angle is supplementary to its adjacent interior angle, you also know that the measure of angle 3 and angle 4, we just said they're supplementary, they're also 180. Make a conjecture. What can you say about the measure of the exterior angle and the measure of its remote interior angles? So here's our conjecture. And see, by pre-typing this stuff, I know in the last videos I was like having a hard time typing things, and so I just pre-typed it off to the side and then just drag it over. So our conjecture is the measure of the exterior angle, okay, and in this picture that's angle 4, is the same as the sum of the measures of its two remote interior angles. That's angle 1 and angle 2. All right, we're going to state this as a theorem. Because it is a theorem, it's the exterior angle theorem, which is our other main idea for our set of notes. The measure of an exterior angle of a triangle is equal to the sum of the measures of its remote interior angles. And this is something that I know you learned in 8th grade, because I've taught 8th grade, and you probably saw it again in algebra. So we're looking at how we can prove that kind of stuff now. Step 3, complete the proof of the exterior angle theorem. Angle 4 is an exterior angle. It forms a linear pair with interior angle angle 3. Its remote interior angles are 1 and 2. Okay, so by the blank, the three measures, measure 1, 2, and 3, add to 180 degrees. Well, that's what we were just proving on the other page. That's the triangle sum theorem. Also, measure of angle 3 plus the measure of angle 4 equals blank because they are supplementary and they make a straight angle. Supplementary angles and straight angles add to 180 degrees. By the substitution property of equality, then the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to the measure of angle 3 plus the measure of angle 4. Sorry, I don't know why I wrote a 3 again. I meant to write a 4. Okay. If we subtract, so we're using some algebra here, subtract the measure of angle 3 from each side of this equation, then what we're left with is the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 4. This means that the measure of the exterior angle of a triangle is equal to the sum of the measures of the remote interior angles. And that's your proof completed. So we've looked at two styles of a proof. This is writing it out in sentences. And over here, it's organized into a table. All right, so this proof is organized into a table, whereas this proof is also a proof, but it's organized into a paragraph. All right, and that is the end of our notes. So I'm going to stop our recording. I hope I was actually recording.